Each individual character we're going to call a bit, and so when I say we need a 13-bit number, what we're talking about is 13 characters. And these are going to be either 1 or 0. So if we have our shape and a binary number, then we can see a 1, and in whatever position it's in, that dot we draw a line to the kth dot next to it. And if there's a 0, we don't. And you might be thinking, well, that's it then. All we need to do is assign all these different features a different binary number, and then we'll be able to decode it in the future. And provided we know the starting point, that's true, but I want to make a system where it doesn't matter what angle you look at the spell from. And so there's one final step before we can finally write down some magic. Let's look at the number 1 in this 13-bit scheme. This is just 12 zeros followed by 1 1 right at the end. And if we look at 2, we have 11 zeros, the 1, and then a 0 after the 1. And the problem with this is that we're able to actually rotate this number. That means move all the numbers right or left, and then if it overflows, just loop it back round. We can rotate this number 2 to give us the same looking symbol as the number 1. So what we do in our system is we skip it. We say, okay, the binary number for 2 we can't use, and then we move on to the next one, which is 3, which gives us a double 1 which we're not able to rotate around to look the same as 1, obviously. And so we assign this to the second feature in our list. So we describe a level 0 spell with the binary for 1, and then we describe a level 1 spell with the binary for 3. And we do this until we have enough binary numbers to cover all the different features and all the attributes for each spell. Where we generate a number, we rotate it around to see if it equals any of the previous numbers in our list, and then if it doesn't, we accept it and assign it to the next unassigned attribute. And so, once this is run, we're going to have a list of a whole load of rotationally asymmetric binary numbers, which gives us exactly the toolset we need to write spells. So no matter what angle you look at this, you can figure out what the k value is, and then from that you can figure out what the binary is, and from that you can figure out what the feature of that spell is. And so, because we now have a unique binary for every different attribute, we can just look at what the features of the spell are and write them onto our shape with the different k values, with a unique symbol for every spell. And what's cool here is this system is actually really flexible. If we have a new spell or a new school, we'll be able to just assign it the next unassigned asymmetric binary. Not only that, we can rearrange the shape of these dots and we'll still be able to decode the spell as we want. Might be a little trickier, but you know, it's done for style more than anything. Which makes sense, because we're making a system for D&D and people want to be able to customize it to their characters. I think that makes perfect sense, but I think this circular shape would be like the default. Anyway, thank you for listening. If anything didn't make sense, let me know in the comments. I'll try again with a slightly refined video.